Hi students, good evening. In this video we will discuss about queues. So what is a queue? In last video we discussed about stacks. Now we will discuss about queues. Here a queue is a linear data structure where insertion is possible at one end and deletion is possible at other end. So here in queues both the ends are open, that is insertion is possible from this end and deletion is from this end, whereas in stack only one end is open, whereas in queue both the ends are open. In queues both the ends are open, that is insertion is possible from this end and deletion is possible through this end. So that is other end. Queue follows FIFO method. Queue follows FIFO method, that is first inserted element, first in first out we will call, first inserted element will be deleted first. First inserted element will be deleted first. FIFO stands for first in first out, that is we call it as first inserted element will be deleted first. Now in queues we have two pointer variables called front and rear. In stack we have only one variable called top, whereas in queue we have two variables called front and rear. So here what happens is front points to first element of queue and rear points to last element of queue. Rear points to last element of queue. Okay, so when queue is empty, front will be 0 and rear will be -1. When queue is empty, front will be at 0 and rear will be at -1. Then if rear equal to size -1, if rear equal to size -1, that is queue will be full. If rear equal to size -1, queue will be full. Now here whenever we insert an element into the stack, whenever we insert an element into queue, rear will be incremented, and whenever we delete an element from queue, front that is front will be incremented. Now in this example here the queue is empty, so front is at 0 and rear is at -1. Now let us take three elements. Some elements like we have one element 10, then second element 20 and third element 30. Now there are three elements in the queue, so the position of rear will be at last element and the front will be at first element. So rear will be pointing to the last element in the queue, front will be pointing to first element. So whenever we insert, rear will be incremented, and whenever we delete, front will be incremented, that is front pointer will be incremented. Now here one very important point, if there is only one element, if there is only one element, both front and rear will point to same location. If there is only one element, both front and rear will point to same location, that is front equal to rear. Then if we delete that element, if we delete that single element, Q becomes empty. Q becomes empty. Q becomes empty. Okay, that is about some points on Q. So Q is a linear data structure where insertion is possible at one end and deletion is possible at other end. From this end deletion is possible. Q follows a method called FIFO, that is first inserted element will be deleted first. In Qs we have two pointer variables called front and rear. Front points to first element of the Q and rear points to last element of the Q. Now when Q is empty, front will be at 0 and rear will be at -1. If rear is at size -1, that is if it is at last location, that is Q will be full. So whenever we are inserting an element into the Q, rear will be incremented, and whenever we delete an element from Q, front will be incremented. If there is only one element, both front and rear will point to same location. And if we delete that element, Q becomes empty. If we delete, Q becomes empty. Now let us see the applications of Q. So what are the different operations possible on Qs we will see. First let us see operations possible on Q. Operations possible on Q. So here we call the terms insert, inserting an element into the Q, 2 delete operation, and 3rd display operation. We will perform these three operations: insertion, deletion, and display. Now here before insertion we need to check the position of rear. If rear is at size -1, insertion is not possible. Then delete also we will check the position of rear. If rear is at -1, Q will be empty. Display the elements. In display we will display the elements from front to rear. Then applications of Qs, where the Qs are used. Qs are used in some scheduling algorithms, in breadth first search, So these are the different applications of Q, as well as these are Qs are used in many cases. In our daily life we can see in supermarkets, at the billing counters we will find Qs, and at bus pass counters, at student counters, different locations. Okay, wherever suppose shared, if there is a shared resource, then one who sends the request first will be served or processed first. Okay, so these are the different applications of Qs. So in the next video we will see